Hello there guys, and welcome back to another epic Inexorable maths video. In this video we are taking a look at the second part of finding the gradient of a straight line between 2 points that we are given. So if we know 2 points we can find the gradient. But I'm going to flip it on its head a little bit on this video, because we are now going to use the same formula, no different formula, nothing new. But instead of finding the gradient of a line that passes through 2 points, we're going to find, given the gradient of that line, the coordinates of the points, or maybe one part of the coordinates. So just like in the last video, we've got the formula here, we've got the two variations of the same formula, they're the same. Two variations of it, whichever one you prefer. This is like the simplified version, but has less information in it. This is the like sort of expanded out version that gives you more information. We're going to be using the same formulas to do something different. So for example, in the first question, we've got two questions here. In the first one, in the question 1 at the top, we've got the line passing through the coordinate 3 minus 5 and 6a has a gradient of 4. So they tell you one full coordinate, they tell you half of the 2 bits of information in the second coordinate. They give you a 6, but not what the y coordinate of the second one is. They just tell you that it's a, which could be anything. But they tell you that it's got a gradient of 4, which is going to help us quite a lot. Find the value of a. Okay, so let's just dive straight into the video. Let's try and figure out how to find essentially the coordinate a using the gradient, using the same formula. Okay, sounds like it shouldn't be too difficult, but it's just something that you need to look out for. So, just like in the last video, we can label our x1, y1, x2, y2. So let's do that. Let's say that looking at this coordinate, let's say this is the first one. We're going to say that x1 is going to be equal to 3, whilst y1 is going to be equal to -5. x1, y1, not too bad so far. Now, x2 is equal to 6, isn't it? Because this is x2. y2, we actually don't know what it is, but we know that it's equal to a, where a is just some arbitrary number that we're looking for. We also know one more bit of information. We also know that m is, where is it? 4. M is 4. And it actually turns out we do have enough information to deal with this and figure out what a is. Okay? So using the formula, using literally the formula, we're going to plug things in. Let's do it. So m is 4, that's the gradient. We're going to say that 4 is equal to y2, which is a. So we're just going to literally write in a, minus y1. y1 is -5. So we're going to have a minus -5, which is going to be a plus 5. Hope that makes sense, okay? Because it's minus -5, so it's a plus now. And that's going to be divided by x2 minus x1. x2 is 6, x1 is 3, so it's divided by 6 minus 3, okay, just like that. Now what we need to do is simplify this and then make a the subject. If we make a the subject, if we put a on the left-hand side or whatever, everything on the other side is going to be equal to just a number. It's going to tell us what a is. So let's simplify this. We're going to then say that 4 is equal to, okay, a plus 5, we can't really simplify that at the moment. But 6 minus 3, we can simplify that. 6 minus 3, of course, was obviously 3. Okay. Now, guys, we're looking for a on its own. At the moment, a plus 5 is being divided by 3. Let's try and get a plus 5. Let's multiply both sides by 3, okay? So then we're going to get 12, because that's 4 times 3, is equal to a plus 5 divided by 3 times 3, which is a plus 5, of course. And then, guys, all we need to do is we need to take 5 away from both sides, because we don't want a plus 5, we want a. So we're going to take 5 away from both sides, and then we get a is equal to 7. At this point here, you can just look at it and figure it out. What is a? Well, 12 is what plus 5? Well, 7. But if you want to do it the proper way, a equals 7. That's the answer. A is 7, okay? So for this one, a is 7. Nice. Let's take a look at the second question now. The line joining 3 minus 4 to minus lambda 2 lambda has gradient minus 3. Find the value of lambda. If you're not familiar with this Greek letter lambda, it is just a Greek letter. It's a constant, just like A, all of the A's. It's a constant just like A. You know, we could have had minus A, 2A, find the value of A, or B or C or any Greek letter, but we're using lambda. So if you're not familiar with the letter lambda, it's spelt like that. L-A-M-B-D-A, I'm pretty sure. If that's not how you spell it, I will superimpose the correct spelling on to the screen right now. But I'm pretty sure that's how you spell it. Okay, so it doesn't actually matter, not part of the question. So this question is actually a little bit harder than the previous one for the simple reason that we actually don't get given any of the second coordinate. All we get given is a relationship between the x and the y coordinates, okay? So the x coordinate is negative lambda, and whatever lambda is, the y coordinate is essentially 2 lambda, okay? So they're related to each other, we get given that, so that's going to help us, but we don't actually get given any number. We just know that the y coordinate is essentially double the negative of the x coordinate, and the x coordinate is half the negative of the y, and that's all we get given. But don't fear, we can do the exact same thing. So let's just have a look. Let's use the formula. Let's label things first. So x1, we're going to say that this is going to be x1, y1, and this is going to be x2, y2. So x1 is going to be equal to 3. y1 is going to be equal to minus 4, isn't it? x1, y1. And now x2, y2. x2 is going to be equal to minus lambda. We're just going to keep it in terms of lambda because that's what we're trying to find. And y2 is going to be equal to 2 lambda, just like that. And again, we have one more bit of information. M is equal to negative 3. The gradient is negative 3, okay? So let's, again, plug everything into the formula and see what happens. That's always, you've got to do these things step by step, guys. So we're going to say that minus 3, because that's m, minus 3 is equal to y1, or y2 rather, minus y1. So y2 is 2 lambda. So we're going to get 2 lambda minus y1, which is minus 4. So 2 lambda minus minus 4 is, again, it's going to give us this double negative situation. We get 2 lambda plus 4. We divide by x2 minus x1 using the formula, and so we get minus lambda minus 3, okay? So minus lambda minus 3, just like this. Now that's an equation. We can solve it. We can make lambda the subject. Again, same thing will happen. If we make lambda the subject, that will be the answer. So it's going to be a bit tricky now because we might need to use some expanding skills, but that's absolutely fine. The first thing I shall do is multiply everything by negative lambda minus 3, or minus lambda minus 3, because that is in a bracket, isn't it, technically, as is this, but that's not massively relevant, but this is certainly in a bracket. So we can multiply both sides by minus lambda minus 3. Therefore, I will do it down here. Therefore, minus 3 times minus lambda minus 3 is equal to 2 lambda plus 4, just like that, okay? So both sides have got minus lambda minus 3 times bigger, okay? So that's just like that. Now we can expand this out. So I'll come up here, do it from over here. So minus 3 times minus lambda, these negatives are going to cancel out. It's going to give us just positive 3 lambda, okay? And then minus 3 times minus 3 is going to give us positive 9. And that is going to be equal to 2 lambda plus 4, which we can't actually do anything with just yet. And now we just need to make lambda the subject. So in either way round you want to do it, what I will do first, I'll take 2 lambda away from both sides. So we'll get lambda plus 9 equals 4, because we've taken 2 lambda from both sides. And then I will take 9 away from both sides, and we will get lambda is equal to 4 minus 9, which is minus 5, just like that. So again, this is our answer. Lambda is equal to minus 5, which means that the coordinate here is minus 5. So this is actually, I'll write it up here, this is actually going to be positive 5 minus 10, this coordinate here, because lambda is negative 5. So negative lambda is positive 5. It's negative 5. And then 2 lambda is 2 times minus 5, which is minus 10. So actually, this coordinate is 5 minus 10. Don't think, oh, lambda's minus 5. Okay, minus 5, not necessarily. You need to plug them back in. Just this, it's a bit of a trick, but this is it. This is the coordinate that we're looking for. But that wasn't part of the question. The question was just find the value of lambda. You wouldn't need to do this unless it actually asked you to find the coordinates of this. Okay, so that's it, basically, guys. That is what you need to know. So just because you get given the gradient, you can find parts of other coordinates, okay? So don't look at a question and think, well, I don't have y2, y1, x2, and x1. I've got the gradient, chuck that out, but I don't have everything, so how am I supposed to do it? You do have everything, you do, because you can use the m, you can use the gradient, and rearrange the equations to find out the values of things like x1, y1, x2, y2, things like that, okay? Thank you guys so much for watching, highly appreciate it, and I'll see you in the next video. Cheers.